must have known who the talk was.
Good afternoon, and here we are again for our Wednesday afternoon seminar series. And I'm very pleased today to introduce a friend and colleague who has been associated with CERIAS and Purdue for a decade or more, and is really acknowledged as one of the leading lights in the area of cyber forensics and computer crime investigation. Professor Mark Rogers originally came to Purdue as a research scientist with CERIAS, and then moved over into the Department of Computer Information Technology in the College of Technology, where he's established one of the country's leading programs in computing forensics, a major laboratory that serves not only people locally, nationally, but around the world. And so it's with great pleasure I introduce our speaker today, Professor Mark Rogers.
Thanks, Beth. Welcome. A little bit of background. This was pretty much whipped together in the last 3 hours, so a little bit of a panicked email came out. Actually, this is a subset of a series of talks and discussions I've actually had with some of the intelligence community regarding this whole concept of the intersection between digital evidence, computer crime scenes, and intelligence. How do we connect the dots? How do we make sense of what we're seeing? How do we actually put what we refer to as meaning and context around raw data that becomes information that hopefully we're going to make some decisions about, which means that we need to turn that data somehow into knowledge. So we're going to call it basically dissecting digital data or context and meaning through analytics. And I tell you right now, we're not going to get a lot of math. This is going to be more of a conceptual approach to some of these issues and some possible solutions. And then I've got a couple of redacted case studies I'll talk about where the courts now, not necessarily the intelligence side of the house, which I obviously can't talk about some of their problems, but what the legal justice system is actually asking of the evidence as far as, well, that's great, but what does it really mean? What can we really answer with this? A little bit of my background, as Spath mentioned, I'm a professor over in CIT, a fellow of CERIAS, and I basically have been involved in the cyber forensics program here at Purdue since I got here, and I've been about 20 years in the field, ex-law enforcement officer from Canada, so you'll probably hear the odd A or a boot. A little bit of an agenda. We're talk about this concept of analysis versus analytics, the universe of data we're dealing with, connecting the dots, and what can this really tell us, looking at methods for connecting the dots, methods for actually looking at, we've got so much information now, how do we make sense of what it means, looking at points of view, and then I mentioned a couple of case studies, and I fully intend to have some time for some Q&A. So, primarily when we talk about digital evidence or digital crime scenes, first thing that comes to mind is this whole concept of it's an investigative model. Okay, it's comes from the background of law enforcement. It comes from the background of something has occurred. It's kind of an analysis after the fact. If you're looking at it as far as a computer security model, it would be one of the, as far as the controls, it would be an investigative control. Something has happened. We need to investigate it. The common questions that are often asked in an investigative model are your W5s, right? Your who, what, when, where, how, and why. This is what the courts are interested in. This is what the evidence is interested in. This is what you see all the time on their CSI shows you see out there. These are the basic investigative questions that we're trying to answer. Well, if we step back, we can say, well, that's only part of the picture. There's the investigative information, but there's also science, and there's a scientific method. The scientific method is really, you look at a theory development. Some theories develop from the body of literature that's out there. You develop some type of hypothesis. You test that hypothesis to determine whether it supports the theory, whether the theory has to be modified, whether the theory has to be evolved. And we look at things like probabilities. What's the probability that retaining the null hypothesis was correct? What's the probability that our prediction was correct? We have error rates, and we're really concerned with things like reliability, validity, and accuracy. And at first blush, it looks like, gee, that's quite a far off distance from an investigative model. You've got the scientific, you've got the investigative. This whole concept of analytics really falls in between that. How do we take things from the scientific and provide information back to the investigative? Analytics is really data-driven. We're talking about data mining. Here you're looking at, from the business world, you want to make decisions, right? You have a large body of data. Somehow you want to be able to make some type of a decision. That decision could be, who should we be marketing this to? Should the packaging be blue or red? Should we add that new widget? And it's based on statistical analysis, pattern identification, and data mining and some of the data warehousing techniques. Now, what's interesting is the business analytics component has been dealing with very large data sets for a long time. What's unique to the investigative world is we now have very large data sets. We have a lot of information. We've been very good at collecting data. We do a very good job of being able to collect data and clone hard drives and create images to the point where we have terabytes and sometimes petabytes of information to go through. What's not good about the investigative model is we still want to answer these questions, but how do we go through all this data to answer these questions? And this is where the analytics come in. As I mentioned, we do a very good job of collecting the data. The universe of data that we're dealing with comes from things like the small-scale digital devices, cell phones, right? PDAs, MP3 players. You name it, we all have some type of a device that, for lack of a better term, is really a smart phone, a small little computer, or some actual repository of digital evidence. We've got workstations, laptops, tablets, iPads, whatever you want to call it. We have this next version, which is basically where we in the digital forensics world have played with for a long time, and that is the traditional containers of the evidence. With the small-scale devices, you include things like your Xbox 360s, your PlayStations, your Wiis, your DVRs, your TiVos, all fall within there. You've got servers, network appliances, and sensors. You have embedded devices now. The ability to embed some type of a computing or some type of logic and logging functions and decision-making functions in things like cars. You've ever heard of the, I'm sure we're all familiar with the Toyota's recall. Okay, now they just recalled the Prius. Oh, it's not a problem with the mechanics. It's a problem with the software. It requires a software update. There are computer chips. There was an issue a while back with the pollution control systems. You could basically cause a car to fail and actually lock up while driving down the highway if a certain error code was actually presented within the vehicle itself. So these are what we call kind of these embedded, these devices that aren't traditional. Then we have what we're calling nowadays, I guess, the cloud, right? You've got things like Google, Google Docs, Google Mail. You've got these very large repositories, whether they're application servers, whether they're actual just storage devices out there on the internet capable of storing a lot of information. The end result of this, having this extremely large universe of data, is not necessarily can we collect it all, it's what do we do with it once we've collected it. It's okay to collect information, but if all we're doing is collecting it and collecting it and collecting it, and we're not doing anything with it, it's really not answering any questions. It's just collecting it. What we want to do in the digital forensics traditional world and in the intelligence community is to actually take that information, that raw data, and be able to make decisions on it. So we need to somehow be able to say what is important, what's not important, and what is completely meaningless because we can't figure out the importance of it. Yes?
So Mark, what's the role of privacy in all this collection? I mean, there's an interesting tension there. Is that going to fit into your talk at all, or can you address that?
Yeah, the issue with privacy is such a large issue, both in the intelligence world and in the forensics world. There's always this need to balance the need to investigate, the need to collect, with the need to basically maintain the constitutional rights and the assumed privacy that we have. The issue that we fall into with this content versus context is within the court system itself, context really can have an important part in whether Spath had a reasonable expectation of privacy on that data because of the context of where that data was in relation to the other data he had in his system. And courts in and of themselves have a very hard time understanding technology. They can barely wrap their head around email. When you start putting the context of, well, yes, it was SPAF's system that had the information on it, but that information really wasn't there. It's a virtual representation of something that's out on the cloud, and that cloud now is actually not a cloud. It's owned by one of the large companies, Google for instance, that, oh, by the way, the terms of service say is Google actually owns that information now, not SPAF. What's the expectation of privacy now on that information, which may exist locally and virtually within that cloud? And that's a really big issue. It's not so much of a challenge for the intelligence community per se. They don't really have to worry about things like constitutional, maybe they should. But it's also, like I said, it is an issue when it comes to definitely within the court systems, jurisdiction, the context, where does it exist, and even who owns it. There's some very interesting court cases in the Ninth Circuit and the 11th Circuit, specifically dealing with community standards over privacy. What constitutes something that would be expectation of privacy in one jurisdiction versus another, because it doesn't really exist in either. But that's about as far as that thought is gone right now with this. But it makes a big difference. What we're really worrying about right now is this concept of content versus context. As much as we'd like everything in the world to be a binary decision, yes, no, it's not like this in the real world. And it's definitely not like this when you're looking at even evidence. The days of, does it simply exist? Does this picture exist? Did that file exist? Did that Trojan horse program exist? Are being replaced with, but what did that mean? So it's not just, is it there or isn't there? But if it's there, well, what does that mean? What does that mean in relation to the intent? What does that mean in relation to the capability of somebody being able to use it? Is it really an indication that that so-called, Trojan horse actually took over somebody's system? Same thing in the intelligence community. Okay, this file exists there. What does that mean? What does that mean from an intelligence perspective? What does that mean from the capabilities of the individual? What does it mean as far as, is that an individual actor, single actor, versus part of a organized group, or part of a much larger foreign national state-sponsored organization? So those are really the higher level questions that we're now looking at taking this data to. So before it was pretty much there or not, existed or it didn't exist. Now we're looking at, that's not good enough. Not only do we have to determine whether it's there or not, but even if it's there, what does that mean? And that is really not an easy answer to come up with. Because again, it's context, it's relationships. And in fact, when you're looking at content or meaning and context, sometimes the absence of something is just as important as the presence. Okay, I think we can think of an example like that. Most systems by default, unless changed, will have the ability, will log most activities. Take a simple example. How important would it be if system X, by default install, always log N activities? You're then called in to look at something, and those activities now are not being logged. So it's an absence of something that should have been there. What does that mean? In a vacuum, can you tell what that means? Because there could have been a whole bunch of different methods that could have happened by, right? It could show intentionally trying to obfuscate data. The person went in there and intentionally got rid of it. It could have been a system error, right? For whatever reason, that service stopped running, the system stopped running. It could have been an update. Somebody updated that, and that new update, for whatever reason, turned those event logs off. Without knowing, without investigating the reason why that lack of N logs occurred, do we really know what it means? Not really, and that becomes very, very important. At the end of the day, while we're very concerned about what the system's doing, we're also concerned about something which is a couple of levels of abstraction above that, and that's what we refer to as the personal narrative of the individual that's responsible. And that personal narrative is only derived at by connecting all these multiple different dots. What was the person doing? What context? What meaning? How does this relate to some of those other questions we're looking at? And this is really what we look at as far as determining the value or the weight of that raw data. And before everybody came in, we're having some discussions with some of the students that have sat through my class about, well, can you really ever have a binary? Is it really yes or no? Can you ever really know with the digital evidence what it means? Can we assign probabilities? These are all excellent questions that we have to start coming up with some answers for. When we talk about analytics, we're really talking about is taking data, moving towards information, right? So data is just this raw stuff. Everybody says, it's the information superhighway, information is important. No. Information is just one step. What's important for any type of decision making, whether it be in a legal setting or whether it be in the intelligence setting, is the knowledge. This is what's important. And how do we get from the data to the knowledge? This is where the analytics comes in. This is where that context and meaning. In order to look at what this stuff means, we really have to look at the totality. How does that physical, the electronic / virtual environment all interact with each other? Think of a situation where you might need to find information that exists on a computer system that needs to tie it to a physical location. Who can think of an instance where that might be important? Okay, you've got some activity on a computer, but you need to tie that computer to an actual physical location. Stolen computer, okay. Any other examples? Accident, yep. In the intelligence community, what they're worried about is you basically think that somebody has been sitting outside of a particular location that may or may not be of interest to attack. Okay, now nobody actually saw that person there, but there's some intelligence or there's some hint that they might have been there at some point in time. You then are given the system to look at, and one of the questions that you're being asked, maybe by the intelligence analyst, is, can you tell us whether that person was at that location? What are some of the things we could do? And not only at that location, was at that location and took pictures with their camera, on their cell phone, or was out on a laptop. What are some things we could look at that would give us an idea of physical location? How about on a cell phone? What do most modern cell phones have now as built into them? GPS, right? You go to take a picture on your phone, and part of the XF data that's actually collected is the geotagging, the GPS coordinates. Okay, gee, that's pretty good. The GPS coordinates say, oh yes, they were sitting right outside, or they were standing right outside of that building taking that picture, as opposed to, oh, that was a picture that they took off a Flickr and somebody else took it. That's pretty important information to try and understand or predict future behavior of that individual, right? If they took it off a Flickr, that means something else then. No, they took that picture themselves, and they were there. How about laptop, wireless card, right? Anything that we can do from that to tie it to a physical location? Okay, search for nearby locations. They're sitting in a Starbucks. They're sitting at Borders. They're sitting somewhere where there's a hotspot, right? A Wi-Fi hotspot. There's an ability then to be able to say, if you get the information off the laptop, you can track the MAC address, you can track information off that computer to, in a perfect world, okay, the logs off that hotspot there and say, yes, they were there at this point in time. Okay, so that's important information. I mentioned what is missing or absent can be just as important. This gives you indication of, if somebody is actively going onto their system and manipulating it, obfuscating it, doing something to make it look like something else, or destroy data, that tells you something maybe about their intention, or tells you something about the sophistication that they have. In some cases, it also tells you something about the finances or the amount of technical capability that the organization they belong to might have. And that can become extremely important to determine, is this person part of an organized criminal group? Is this person a lone actor that's part of a group that is now organized for a single attack and they're not going to continue afterwards? Does this person have, deep pockets, or this organization they belong to have deep pockets? And these are really important questions, both on the intelligence side and on the forensic side. So what can the data tell us? Well, it can tell us the context, okay? Again, looking at data in a vacuum, and for the most part, the flaw we have in most of the current tools we use in computer forensics is they do exactly that. They show us things in a vacuum. If you look at how most of the interfaces work for this, they show us the file structure. They show us what the file system looks like with directories. They don't show us what that desktop looked like. They don't show us that, oh, not only this file is in this directory, was in their desktop, but it was in the desktop right beside the picture of their parents. Does that mean something? It might. Think of yourself. Think of your own desktop that you have. Your desktop, not on your computer, your desktop at your desk at work. What do you put on your desktop? Information that's important to you, information that you want to have access to really quick, pictures of your family, your loved ones, your sporting events that you're interested in, things like that. Okay? If you're SPAF, it's cartoons and jokes. But does that tell us something about SPAF? You bet. But it's stuff that's important to you. The same thing that you do with the physical, we tend to do in the electronic. And this is really how the human-computer interface people have designed this to be that way. Why do you think they call it a desktop? Because we're familiar with what a desktop is. We can make that analogy. So we tend to, as users, use the systems as if they're extensions of physical space. But when we're looking at it with most of the tools, we see it as a file system, database structure, with no real meaning or connectiveness between all these different points. And that's not necessarily a good thing. Meaning, I talked about this personal narrative. A good friend of both SPAF and mine from University of Central Florida, Mark Pollitt, is working on his PhD dissertation. Mark is the former director of the FBI's computer analysis response team, and he was, in fact, in charge of that during the 2001 9/11. So he's taken a much easier road and gone to academia. Retired academia working on his PhD. He did an excellent little white paper on the concept of the personal narrative and what that means to understanding what's going on. The personal narrative is really the life story of that individual, what is meaningful to them, what is not, what is information that tells you who they are, who's important to them, and what's important to them. And that's really what we're looking at when we're trying to connect all these dots. So what else can the data tell? How about linkages? Okay, you get 57 laptops. Okay, how do you tell who was talking to whom? How do you tell if that individual, it really is just a tourist that happened to be caught up at the same time that everybody else got arrested that were part of this supposed gang? How do you figure out who's connected, who's linked? Well, this is where you're going to have to start connecting the dots. This is where you're going to have to start saying, what is common to each of these laptops that wouldn't be common just by default? Gee, start looking at things like social networks, right? Who's been talking to whom? If 7 people are the group of 50, all have each other's contact information, birth date information, personal residence, cell phone, private email, and they're all friends on Facebook, that might mean something. Okay, that might be a clue. But without getting information like that, simply trying to guess who's related, we can't do that. And this is extremely important for answering a lot of the questions. Some of the most important questions are, what are the intentions of the individual? This is important from law enforcement, definitely important from the intelligence community. What is that person's intention? The intention of the individual as well as the intention of the group. This becomes important. There's a lot of debate right now whether we're actually seeing organized criminal activity or organized crime activity in cyberspace right now. The different vendor surveys would love you to think that this is happening in mass and they are so sophisticated that now you're going to have to pay more money for more sophisticated controls. Well, there's another camp that comes out from the traditional criminology area that says, whoa, 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 slow down a minute. We have to differentiate between organized crime. And organized crime have a structure, they've been around for a long time, they have hierarchy, they have lines of communication, they run like a corporation. Versus criminal organizations, which could be, for the most part in cyberspace, they tend to be single actors who get together. It's kind of almost like a viral type of an event. They all decide, they get on the check, and say, hey, yeah, it would be really cool if we went and attacked so-and-so. an example of a criminal organization, or organization for a criminal, not an organized crime group. Anybody hear of 4chan? Okay, there's a couple of cases. They were actually part of the case coming up with the I guess the bomb threats that Purdue and other universities were getting a while back. Okay, now is that an organized crime group? It's a bunch of individuals that get together and decide, let's go swarm virtually something, right? Well, it might look like on the surface that it's a organized crime group, but it's really a criminal organization for the purposes of that one attack, and then after that they all spread out and do something different.
How about RBN?
What's that?
RBN.
RBN, yep. Okay, so it's important to be able to know what's going on there. To make it, I think there's going to be a difference in how you would go about dealing with a group that is an organized crime syndicate versus RBN or these other groups that get together. Certainly, it's going to be entirely different. How do you know it's not a foreign national or a government, foreign government supported actual cyber squad attacking that doesn't want to make it look like it's just an individual lone actor? So that becomes extremely important. These are questions that keep the intelligence community awake, and questions the courts want to know. Because obviously, the most obvious defense that comes up is, well, I'm not a member of this organized group. Happened to stumble on there and seemed like a good idea. What a dumb person I was. Meanwhile, they're being heavily financed and they're very sophisticated. That makes a huge difference. Social network, that becomes important. How big of a social network do they have? Who can they reach out to? Are you really just, basically looking at the tip of the iceberg? Technical capacity. What technical capacity does this group or this individual have? Resources. How much resources do they have? These are questions that, if you look at from an intelligence community perspective, you have your technical people. Technical people would get SPAF's computer. They'd be asked to basically do all their stuff to it in a forensically sound manner and pull everything out and make copies. Then the intelligence analyst comes on and says, okay, I have to take this data and somehow answer all these different questions. Are these things I can answer simply looking at this data that exists on that laptop? And the basic answer I always give them is, it depends. It depends if you and the technical person can get together and understand where that came from. If you're just going to look at things in a vacuum or not communicate, then it's going to be really, really hard to understand where those things occurred. Because yes, I found all these contacts, but where were they? Were they in the calendar, or were they in Slack space? Were they something that was deleted, it was off a web? Where did they exist? All that becomes extremely important. Organizational structure, organizational activities, environment. The last one is really important. Pattern of life. Wow. Why would the pattern of life be important from an intelligence perspective or from a simple investigative perspective? Pattern of life is, what does a daily activity of that individual look like? Why would that be important? Why would you want to know what they do first thing in the morning until they go to bed at night? Yeah. Oh, actually hit your... Talk loud. Look for abnormal behavior. Okay, but why? Why do we care about abnormal behavior?
They come in earlier than usual.
Okay, so you're starting to look for somebody that's exhibiting indications that they're doing something they shouldn't be, right? Yep. What else? Yeah, SPAF.
Because it could establish an alibi if someone is using their system.
Exactly. Okay, maybe that Trojan horse defense is true, or maybe they weren't there. Maybe somebody else did get on. Okay? It becomes important to understand, if you're going to try and do surveillance on this individual, what do you need to do? You need to understand what time they get up in the morning, where they go, what route they take to get to their job, whether what they do when they get there, what floor. You need to know all this information. You're looking for patterns of behavior. In your case, you'd be looking for patterns of behavior and then basically a deviation from that pattern. In SPAF's case, you're looking at the person says, hey, between 6 in the morning and 10, I'm at the gym, I'm not even home. How could I be on my computer and doing that? So patterns of the life pattern, that information actually can be answered with looking at the data, potentially, simply on that system. You can look for things like, gets up in the morning, first thing they do is they log in at this time and go check their email. Yep.
So just to return to an earlier point, this is a very interesting aspect of privacy,
Oh, yeah.
because we can say, all right, well, 3 days a week they're spending time over in an apartment that they're keeping separate from their house.
Yep.
So that's a privacy issue. There are also some interesting personal security issues here because you use the same things if you're going to plot a kidnapping or an assassination. You want to plot out the movements to know what to do, or get in to plant a listening device,
Yep.
or so there's a whole variety of motives behind it
Oh,
that I think are worth bringing out.
oh yeah, exactly. And this is pretty much everything we're talking about here can be used for both a positive and a negative. Hopefully, for the most part, we're going to assume that with most of this stuff, we're going to be looking at it from an investigative with the privacy controls in place. But you're so right. One of the biggest things they warn when you're looking at hardening the target as far as executives who are traveling in foreign countries or possible kidnap is you change your pattern. You don't do the same route. You become very aware. But the same information on the flip is a positive when you're looking at Spaff couldn't even done it. He wasn't even home. He was having coffee or flying to
Lost again, where is he?
pull, or he got lost. He's out driving in his car. Connecting the dots becomes, it's easy to say, oh yes, we can take all this great stuff and we can wrap all this magical context and content on it and look at what it means and figure it out. But how do we do that? How do we do that when you've got 5 terabytes of information to look at? And, oh, by the way, you've got tools that were designed to connect the dots when a 10 meg hard drive meant you were a super user. Guys, these are not easy questions. This falls into the realm of the sciences of information retrieval, database. All these need to come together to try and make this information mean something. One of the ways that you need to connect the dots, or one way to connect the dots, is something called pattern analysis. What patterns appear when you look at this? Chronologies, timelines are another kind of a fundamental. How do we know what occurred when? Timelines, cause-effect relationships. We look at A happened, then B happened, then C happened. And timelines are something that I think we struggled with in computer security in general. How do we understand it? How do we trust the timelines? What do these timelines mean? Frequency analysis, that's another potential area for looking at this. How often did this occur, did X occur versus Y? And what does that mean? How often did they send email to this particular subset of IP addresses? Gee, could that mean something? Again, it depends. It depends upon the context and depends upon the meaning of everything else around it. Hierarchical connections or nodes. This is really an interesting way. Everybody hear of the 7 degrees of separation from Kevin Bacon? Okay, basically, you try to figure out, okay, you got Kevin Bacon, and you take any actor or actress in Hollywood, and the game is how quickly can you take it back to them somehow being associated with Kevin Bacon? Through the movie he was in, through somebody he's dated, or through something else. And it's really interesting kind of a party game. Well, that goes back to what's called small world networks. Yep.
I'm 3 separated.
You're 3 separated. Yeah, it's really interesting. And there's been a lot of research done on these small world networks looking at degrees of separation in social networking, densely connected nodes. So not only can we look at what's on that system, we can go out now and look at your social network. We can look at who is connected, who are you connected with, and if we can find that virtual Kevin Bacon that everybody's connected with, wouldn't that be, from an intelligence perspective, wouldn't that be a brilliant place to go plant all our listening devices? To go look at. From a privacy perspective, that'd be something we want to protect. If that's a super connected node, we want to make sure that there's some controls around that, so you just couldn't drop in there and now have information and have knowledge about a whole bunch of other seemingly unconnected. And this is something that is kind of the holy grail right now of what they're looking at out there in the intelligence surveillance world related to this. But it means something. We can find those super connected nodes, we can find those Kevin Bacons, we can get an idea what everybody else is doing without having to look at Spaffs separately, and that person's, and that person's, and that person's. And the structure of social networks falls right into that. You have very connected people who are friends with a million other people, right? So maybe if I want to find out what 50 people are doing, if I can find the one person that all 50 people are friends with, what can I do? I can go to that one Facebook page and I can look for what updates people or what people are doing. So we find these hyper-connected or super-connected, densely connected nodes that gives us information related to the social networks and the groups and what everybody else is doing. Scott's going, oh, this privacy, this isn't looking good.
So just to wander off a little bit, there are a whole lot of issues that the superconnected nodes are actually the ones that you may want to avoid because they would be in a position to notice anomalous behavior of other elements in the network.
Yep.
And so knowing who they are helps you target nodes without the information rippling to the rest of the network.
Yes, and so basically, that's the flip side of that. A lot of stuff in the whole P2P, the whole idea of these peer-to-peer networking, a lot of that has to do with a lot of the surveillance that's being done on a lot of these very connected nodes within the P2P. So either avoid them, or that's where you want to look at for people coming in off.
So an example that I've seen recently, although I haven't seen a write-up of it, and some of you may run into this, is on Facebook. A common tactic there is if someone's account is compromised, one of the frauds is to send email to everybody who's a friend saying, I'm in London, I've been robbed, I don't have my passport or any money, I'm in desperate straits, can you wire some money to me? I had a few people fall for that.
Yep.
But it turns out that the hyper-connected individuals are those who are immediately able to say, oh no, I know where Roger is.
That's right.
And he's not in London, don't fall for that. So in those cases, it's a protective mechanism.
Yep, kind of a gatekeeper to that. Yeah, exactly. So that's why it's important to know who these are, to either avoid them or to be able to subvert them in a way to collect the information. Visualization is another way. We're visual beings. We look at things like graphical representation, heat maps, which things are red, which things are green. There's some really cool software out there that looks at, you have all this data from a computer system or from all these different drives or from a database. Based on the colors in there, they can represent something that may be of interest to you. So rather than just seeing a file structure with directories, they'll give you, if the size of the file is in excess of X, it will show up as this color. So, or it's between this range. You're involved in a case, and let's say we're looking for somebody producing child pornography movies, and we know the movies are within this range on average of sizes. You could actually use this, then I'll show me all the files then on this computer in red that would be within this range. Boom, comes up. It's much easier for us to look at from a heat map type of a structure than it is to start looking through by hand to figure out how big these files are. Dashboards are console UIs, user interfaces. These things come up and show us in a restricted view, so we're not being overwhelmed with information, patterns and queries that we've asked for and that we've looked at. Timelines is kind of the more basic way. This is kind of how we started doing this. And timelines are great if we assume we can trust the timestamps on any of these things. And without getting into a lot of detail, that's a big question mark. Because timestamps, it's a user-controlled activity. You can change it. You can change clocks. You can have system failures. You've got the concept of clock skewing and drifting, where even if the clock is set accurately to the network time protocol server, after about an hour, depending upon how the system itself, 5 minutes could be off, half hour could be off. By the end of the day, they could be out by 2 hours. There's been some interesting research done out of Australia that shows you, just from systems left alone on their own with no manipulation by anybody, how much the clocks have drifted and skewed from one day, 1 week to the next. So it makes timelines, that's the most basic way of doing it, but at least it's a start. Something that's coming up a little bit more recently, especially in the intelligence world, is this concept of mind maps. How can you drill down? How can you look at these dependencies, these interactions, in a way that, okay, I want to look at this. You click on that, and it shows you the connections. It shows you which things are connected, and not just which things are connected, how connected they are. And you can drill down, you can do fly-throughs, you can stand the data on its head and look at it from different perspectives, and potentially get a micro view, back it off, and get a macro view. And sometimes, the old saying, you can't see the forest for the trees. You're looking at the stuff at such a lower level that when you back it back out and look at it, go, wait a minute, This stuff is actually connected on a much higher level that you don't see if you're just looking at individual files within a directory structure.
And they're binary trees.
Yep, binary trees. Yeah, lot more ways of doing it. Okay.
Forest with the binary.
Voice of the binary trees. The courts are asking this now, and it's not just the intelligence world. There's two cases that that the courts have that I know of personally that I've been involved in, where they've come up and said, "Great, we think this individual is guilty. We're not asking you to weigh in about guilt or innocence. We're looking at okay, but what does this mean? This individual, if this person is a pedophile, the person has been is doing this. How much of a risk are they to be a contact offender? If you only find X number of files on that computer, is that person a preferential offender versus a situational offender? And what level of offender would they be in there? You cannot get that type of information or come up with that type of determination 100%. It's going to be a probability estimate. And you can't do it by looking simply at that file was there versus it wasn't there. If you're looking at a case where you've only got 2 child porn pictures and there's no adult pornography, there's nothing else on there but these 2 child porn pictures, well, is that person a situational, preferential, or did somebody actually put that stuff on their computer? And in order to do that, you can't just say, yes, those 2 files existed. Those 2 files existed, but this didn't exist. And it existed here. And it doesn't fit within this, and you're not seeing that. You pull these things together. A real interesting case came down to competency. Oh yes, my client did that, but it's such a low level of functioning that they didn't understand what they meant, and that they're such a low level of functioning that they didn't understand what the software did, and they weren't really a sophisticated computer person, so they weren't aware of the dangers of putting LimeWire and BitTorrent, and that they could actually have child porn downloaded in there. The question comes back then, looking at this totality of the evidence in front of you, can you make a determination, without interviewing the person, of how competent that individual was related to these defense theories that are being put forward? That's a lot harder question than, was that file there or not? It requires a lot more information, a lot more time. And in fact, this was actually a court-ordered evaluation. So, okay, if your client wants to actually do that, we're going to actually make them go through some type of screening, or they might have to have some type of court-ordered evaluation. But part of that is, let's look at, did the Trojan horse really plant that software on there? Or are they competent enough to manipulate it to make it look like that's what happened? So these are really, really tough questions that we have to get involved in. And like I said, they're a lot more than just looking at the data. They're a lot more than just looking at, okay, we got some investigative questions. In order to get to the investigative questions, to be able to answer them, and not just answer them in yes or no, answer them and be able to say with some degree of certainty whether that answer is correct or not, requires this whole concept of the analytics, requires this whole concept of context and meaning, and the ability for you to develop this personal narrative, and the ability to understand what this stuff means versus what it might not mean, versus it's meaningless. Like I said, these are not exactly easy questions to answer. So it really is not all about the data, and this is where we really like to say, okay, we can just collect, if we collect everything, we're good. Well, what do we do with it? And it really is not all about the information. Okay? It's really about the knowledge, and we only get that through understanding all the interconnections, connecting the dots, and really looking at what is the actual meaning, what is the context, and how this relate to any of those questions, if you can even answer any of them. Now, I got room for discussion, but I just wanted to see if I could get this to come up for a second. I've actually got a small little, this should work, small little example of a mind map related to one of those simple questions I asked you about, okay, we need to get information related to a physical location of that system. And what can we use to do that? I'm just thinking this may or may not work. Okay, are you seeing that now? Okay, I'm just going to open it again. Okay. So this is just a very simple mind map, okay? And one of the analytic questions is physical location of devices. We want to know where that device existed. Well, what can we look at? Okay, well, maybe things like MAC addresses, network interface card, non-volatile memory, output virtual versus virtual memory page files, P2P applications. We may also want to look at volatile memory, okay, web browsing and the wireless card. Well, how could any of those artifacts, any of those pieces of data allow us to answer that question? Well, let's go to P2P application. Maybe there's some country-specific settings or versions of that. Language modules. Stored network settings for the P2P device or for that or the P2P network. That's going to allow us to roll that up and be able to answer some questions related to where that device may have been located. Wireless card, we talked about that earlier, right? The wireless card to that hot point. Think of your cell phone. Quite often now, some really sophisticated questions are being asked, not about where the person necessarily was, but what side of the tower were they on? What side of the antenna was that individual on? Because the side of the antenna could make the difference between they were on this side of the county line versus they were on that side, or they were on this bridge versus this other bridge, which can become very important for what Spaff talked about, the alibi. Really important information. Okay, well, what about, let's see here. Okay. Volatile memory output. Okay, was there anything in there related to cached anything? Printing. We could tell what printer it was stored to. That person actually took that laptop, walked into that person's office, had connected to that printer, and had done something. That gives us an idea of the physical location. What information could be stored in there? Web browsing. Localized browsing data. What information on there tells us about time location, local events, history file artifacts. And you can start actually drawing with this the connections between all these. Where do these things all meet up? So this is just a simple way of taking a very simple investigative or intelligence question about, okay, I have this device, how can I tell where it's been? And mapping the information, the artifacts, the data points you need to start making the decisions as to, A, can I answer the question? And B, if I can answer the question, at what level of granularity can that question be answered? So this, like I said, this is just one example of a mind map that's used for that. So I think we have enough time for some questions. No questions?
They're afraid you'll track them from
I think what we're seeing is, let me just throw something out. In my opinion, this is becoming very, very important areas to start looking at, because as we become more comfortable with technology, the questions we ask of it become more complex and more complicated, and the information we want. At one time, when I first started doing this about 20 years ago, it was, was that file there or it wasn't? Now it's, well, could it be a Trojan horse defense, and what does that mean? As people start getting more familiar with technology and its limitations, then the challenges start coming out as, well, you're telling me it was, how do you know it was actually him that downloaded it? Because anybody could have been behind the system. It starts becoming more complicated, and a lot more, I think, intelligent questions are being asked of the information. Right.
Do you see digital forensics ever going in the direction where, in order to get a court order to analyze a drive or some storage media, the court order only allows you to analyze a certain part of that drive and not the whole thing?
Yeah, I'm actually, if I was to make a prediction, I'd say we're going to see that pretty quick, because the court challenges to these fishing expeditions or these overly broad or general warrants, which is really, if you look at the history of the protection from unreasonable search and seizure, the last thing they want are these general warrants where you can look for everything. I don't know whether it's going to specifically say portion of the hard drive. I think you're going to see the introduction of constrained tools, or tools that constrain the view. So if you're going and looking for you're working on this type of case, and the court says you're only looking at spreadsheets or information X, the tool then will ignore this other information and only show you this. Now the danger with that is you lose the context. By looking at it constrained, it might mean something here, but when you look at where it was in relation to everything else, or shadows, or anything else that was related to it, that might mean something completely different. So I know the defense is wanting it, yet they're not wanting it, because they know By wanting it, they could get rid of the context and meaning that sometimes supports the defense's legal theory, or may not supports it, but casts a shadow of doubt that it could have happened in more than one way. But yeah, the courts are really looking at this whole concept of, we wouldn't let you do that in the physical world, look for everything. Yeah, maybe maybe the computers aren't that different. Maybe the virtual world isn't that different. I think that'll really happen when we start getting into the cloud computing. And you're not going to be able to look at everything in Google's cloud. You'll be able to look at a specific subsection that that the court authorizes you to look at, and that's it. Because the cloud is just, where does it stop? Stop.
Well, I'll address this to the audience. So Mark has given this presentation, and he has given us examples, the intelligence community, the law enforcement community, using forensics. But let me just say, there are other uses of this, where this is going to be important for those of you working in computing as you go forward. So for instance, in a corporate setting, you may want to find out who was it who sent the harassing email, or who was it who leaked the trade secrets to a competitor, who was it who accessed the company servers to get salary information they weren't supposed to. That's not a law enforcement purpose per se, because that may be a civil case, that may even be something that's kept within the corporation for their own value. So there is an obvious place where that may be used. Another place is when we're talking out in the civilian infrastructure. I mentioned one example, for instance, but very often people have lawsuits against each other about what they knew, when they knew it, relationships, interference with relationships, other kinds of property ownership. And so a lot of that, being in the online realm, is going to now be of interest when we start looking at civil suits. So certainly the place where that's been exercised is DRM for unauthorized downloads, but it covers a much wider area as the legal profession begins to move into this and pays attention. And then, again, another example that I gave, but there is a whole area of concern, both of forensics and anti-forensics, in the area of personal protection. This is not something you see a lot of, but celebrities, business executives, government officials, and the paranoid, for various reasons, criminals, want to protect their movements because they are possibly targeted for revenge, people who have mental illnesses, people with political agendas, people interested in extortion. And so as much of their life that's online and that of their families and their resources, that information is not only of interest to the law enforcement community that may be investigating them, but is also going to be of interest to those individuals who might want to harm them or take advantage of that. And therefore is also of interest to those who may want to protect them by finding ways to obscure that information. And so you get into this very interesting back and forth that will continue. And I just want to give that as a bigger picture. So if you look at this, it's not really limited just to those agencies of a government that may be pursuing a wrongdoer, but it's a much bigger area that's going to have lots of impact on your lives in the years to come, assuming we still have enough energy to run computers.
Yeah, and it's definitely a personal privacy issue as well. A good example is Bass talking about. Look what's happening in Mexico right now with basically revenge killing by the cartels on the government people and their families and informants. It's an absolute nightmare, and they're turning that same technology, they're turning the same type of information gathering against the governments and using it to target individual people. The other thing is, as more of this context, as governments and entities and corporations and businesses are tracking more and more of what we're doing, as they start developing a personal narrative that becomes very accurate to you, that's incredibly invasive from a privacy perspective. Now you can connect the dots that you don't even want connected because it's none of their business. Or they connect the wrong dots and they get a completely different picture. We're getting more and more things on us that allow us to be surveilled than ever before. It's not just the cameras that are out there at the intersections. It's the GPS that's built in, the OnStar. Okay, it's the cell phone. It's the cards that you use at the grocery stores. It's the what is it called? The more secure ID that we're going to use, supposedly using for driver's licenses that have supposedly have the RFID chips and everything. As more and more of that is available, you'll see more and more of a push to start being able to build personal narratives on everybody. And that is a huge concern. So yeah, I'm talking about the context of an investigative from that side, but there's always the flip from the privacy, from the social and public policy, and it's bad when government does it. It's bad when private citizens can do it, on themselves, and it's bad when corporations are able to do that on you. There was a big issue out in California a while back. One of the middle schools wanted every kid to wear an RFID chip in the school so they could track where they were. The idea was the kids were playing hooky. The parents went ballistic, saying that's none of your business where my child is if they're not here. Or, that's totally invasive. But the technology's there to do it. So, no questions? No concerns? No fears? Paranoid, everybody turns your phones off now?
Delete everything off their phone.
Yeah, well, that doesn't work either. Okay, well, thanks very much. And like I said, this is an interesting area.